My first step is to zero the output slit width until my beam just vanishes. So in this case, I'm going to close my slit, and you'll notice the beam become more and more narrow until it finally vanishes. And I can open this back up, close it again, and open it back up until I find this 0, which for me is at a micrometer setting of 3. Now we will open the slit 7.5 marks from my 0. So I'm starting from 3, and I'll start counting now. 1, 2, 3, 4, 5, 6, 7.5. So I've ended up with a very narrow slit, a very narrow beam. Now let's set the back slit. I'm going to open my front slit a full turn so that I have plenty of beam to look at. And now I will close my back slit until my beam disappears. Notice that the slit width stays the same. It's because that's determined by my output slit. So my input slit now is close to 0 because my beam has just vanished, and I can move back and forth until my beam just appears, and I'll back off, and my 0 is where my micrometer reads 25 in this case. I'm going to start from my micrometer position of 25 and increase 7.5 marks on my dial. So here's 1, 2, 3, 4, 5, 6, 7.5. And you can see I have a fairly faint beam. Finally, we'll go back and reset the output slit to my original location, so I can back this off until my slit just disappears. There's my 0 again, and I know to advance it 7.5 marks. So now both input and output slits are set to 75 microns, which should give me approximately 0.8 nanometer line width, which is great for checking the calibration of my xenon lines.